Towards the last week of June 2026, 4 independent technical signals landed within days of each other, and they're all about the same thing. I mean, while one of them is a hardware play, another one is an architecture trick. Another one is a training breakthrough, and the last one is a decoding method. And they all point to the same structural event. Per token inference cost at long context is collapsing faster than the frontier model benchmarks suggest. And this means the remaining companies that still price inference like it's 2024 are about to be repriced by the market. Let me explain. What does pricing like 2024 mean? In late 2024, a GPT-4 class inference hit roughly $1 per million input tokens. The frontier providers, such as OpenAI, Anthropic, and Google, all calculated their prices at $2 to $15 input and $8 to $75 output per million tokens. The justification was the same every time. Frontier quality requires frontier compute, and you pay for the parameters you activate. The entire pricing architecture of the API layer assumes that relationship holds. The assumption is that better models cost proportionally more to serve. That serving a 700 billion parameters model at 1 million token context is structurally more expensive per token than serving a 70B model at 128K context. That assumption was never permanent. It was a byproduct of a specific moment in hardware, architecture, and software stack maturity. And in the last 7 days, 4 separate breakthroughs just broke it from 4 different directions. Imagine the inference cost was held in place by 4 locks. And first on the list is the supply lock, whereby only a few hardware vendors control the chips that run inference at scale. The next is the compute lock, and it basically explains attention over long context scales, quadratically. You pay more per token as context grows. And then we have the scale lock, which serves better reasoning but requires bigger models, and bigger models cost more to serve. And the last is the speed lock, and it explains that autoregressive decoding is sequential. You can't parallelize token generation. All these locks are independent and necessary. If you break any 3, the 4th one will still hold the cost floor. But if you break all 4, the cost declines and it structurally collapses. And last week all 4 got hit. Let's break it down. Regarding the supply lock, we all know Google is selling TPU capacity externally. Well, if you don't, now you know. So Google announced Ironwood, their 7th generation tensor processing unit, which was explicitly designed for the age of inference. It is more than a research chip, it was a strategic focus. So basically, Google builds TPU capacity for external customers the same way Amazon Web Services builds Graviton capacity. And it was revealed that Anthropic committed to up to 1 million Ironwood TPUs in a multi-year Google Cloud deal that was signed October 2025. And this deal means Anthropic has an inference capacity that doesn't route through Nvidia's GPU pricing at all. Now this matters for cost because the inference hardware market is almost a monopoly. The Nvidia's H100 commanded $30,000 simply because nobody could serve the same workloads at scale without one. So consider the scenarios whereby Google sells TPU capacity to third parties, and when Amazon sells Trainium or Inferentia, and when Grok sells LPU capacity. They all indicate that the price of an inference GPU hour is no longer set by one vendor's margin. Instead, it is now set by the market. It means the supply lock has been picked. All right, the next discussion on the list is the computation lock. And GLM 5.2 essentially cuts floating point operations per second by 2.9 at 1 million context. So JIPU, otherwise known as ZAI, released GLM 5.2, which is a 753 billion parameters mixture of experts model with a 1 million token context window, open weight, and MIT license. So the headline numbers are the benchmarks and the architecture is the story. GLM 5.2 implements something called IndexShare, and the mechanism is, in standard sparse attention, every layer independently computes which tokens to attend to. And it's expensive because you're running the indexer, which is the mechanism that decides whether the tokens matter or they don't at every single layer. All right, so IndexShare reuses the same indexer across every 4 layers. So basically, the indexing decision that was made at layer n also governs layers n plus 1, n plus 2, and n plus 3. The bet is that the set of tokens worth attending to will not change between adjacent layers. And the benchmark has confirmed it holds. So the result is basically a 2.9 times fewer flops per token at 1M context. Also, approximately 4 times key value cache reduction at long context. And it's not because the model is smaller or because it's quantized. It basically means the architecture itself has less redundant work to do. And it is important because the compute lock's fundamental assumption is that attention cost scales with context length multiplied by model depth. IndexShare is breaking the proportionality with depth, and the cost curve over context length is bending. At 1 million tokens. That bent curve is 2.9 times cheaper to traverse. This growth is slower than quadratic. All right, the scale lock. It is a 3B dense model that scores 94.3 on AIM26 and 80.2 on LiveCodeBench v6. Vibe Thinker 3B is a 3 billion parameters dense model from Weibo AI. 3 billion. It fits on a single consumer GPU. Its brain floating point weights are 6 gigabytes. On AIM 2026, it scores 94.3. For reference, DeepSeek version 3.2 scores 94.2, and that is a 671 billion parameter model. Kimi K 2.5 scores 93.3 at 1 trillion parameters. Essentially, Vibe Thinker 3B is matching models that are 200 times its size on verifiable reasoning. This model achieves elite math scores using a post-training pipeline called spectrum-to-signal S2S. Think of it as a two-part process. First, you build a wide range of possibilities, and then you pinpoint the exact winning strategy. Supervised fine-tuning, or SFT, builds the spectrum. So instead of teaching the AI just one way to solve a math problem, it trains the model on a massive variety of valid reasoning paths. And the goal here is to give the AI a broad and flexible landscape of logic that it can pull from. Reinforcement learning, or RL, isolates the signal. It sifts through that broad spectrum and aggressively amplifies the correct answers while muting the wrong ones. It is a technique called max-ent guided policy optimization. The training doesn't waste time on questions the AI already knows, or questions that are far too hard. Instead, it targets the capability boundary, which is basically the exact edge of what the model can handle. This is the sweet spot where correct and incorrect answers coexist, and it's essentially where the most intense learning happens. After intense reinforcement learning, the model can get a bit chaotic. So a self-distillation stage takes the best parts of different RL training steps and merges them back together into a clean, single brain. And then a final but quick instruct RL stage cleans up the rough edges. So this last step fixes the formatting bugs, stops repetitive loops, and ensures the final math output is clean and can be easily understood. All right, that was a lot, but this matters for inference cost because previously, the assumption from the scale lock is basically better reasoning requires bigger models. Now, Vibe Thinker 3B has proven that for verifiable tasks including math, coding, or STEM, a 3 billion parameters model with the right post-training can match a 671B model. And the inference cost ratio is on the order of 200 techs, unlike the compute lock 2.9 times. You can literally serve this model for fractions of a cent per million tokens. And once again, the scale lock has been picked from the inside. Can you see where this is going? All right, moving to the speed lock. TiDAR delivers something that serves up to 5.91 times more tokens per second, with zero quality loss, although the lower range is closer to 4.71. So TiDAR, which means think in diffusion, talk in autoregression, is a sequence-level hybrid architecture from Nvidia research. And yeah, the name is the mechanism. Autoregressive models generate tokens one at a time. Each token is conditioned on all previous tokens. You cannot start a new token n plus 1 until the previous token n has completed. So that's the speed lock, and decoding is naturally sequential. TiDAR breaks this by running two paths in parallel. The first path is a diffusion-based draft model that generates multiple timings simultaneously. It thinks in diffusion. And then, during the second path, An autoregressive model verifies whether to accept or reject the draft. It talks in autoregression, which preserves the quality guarantee. It is not another speculative decoding with a smaller model. We already know that traditional speculative or autoregressive decoding uses a smaller AI model to guess future words, and then a larger model verifies it. And as explained earlier, this method is causal, which means they must generate text from left to right, one word at a time. And it means the third word cannot be guessed until the second word is completed, and this step-by-step guessing slows everything down. Again, the speed lock. So TiDAR is doing something different. Instead of using a standard text model as the drafter, it uses a diffusion model as the drafting mechanism, and it does not have this requirement of generating from left to right. Diffusion starts with a blanket of random noise across an entire block of text, and then everything is refined all at once. And again, because the ordering is not sequential, TiDAR can use bidirectional attention to guess a massive block of future words simultaneously in a single parallel sweep. So instead of running two separate models, TiDAR does everything inside a single architecture and then divides its attention into three zones: the past, the present, and the future. The past looks at the words had been written already and reuses its memory cache. The present instantly verifies the guesses made in the last step. And the future generates the next large block of guesses for the upcoming cycle. To put it simply, diffusion can propose an entire sequence in one forward pass, and the autoregressive verifier then checks it in one pass as well. And as explained earlier, the results show 4.71 times speed up for the 1.5 billion parameters variant and 5.91 times for the 8 billion parameters variant, measured in tokens per second. Okay, with zero quality degradation, TiDAR is the first architecture that closes the quality gap with pure autoregressive models while delivering this kind of speedup. And yes, it matters for cost, because inference pricing is basically cost per token multiplied by total tokens processed. A 5 times throughput improvement means every GPU hour serves 5 times more requests. And that's a 5 times reduction in the hardware cost component of per token pricing, all without any change to the model, the hardware, or the workload. All right, now let's put the 4 signals together, because the pattern is not inference is getting cheaper. Although that's also true, like we can observe. What changed in the last week is why it's getting cheaper, and how fast the remaining decline can go. The cost decline was driven by 4 compounding factors, which are hardware efficiency gains. For example, GPUs are now generating 3 times better throughput per dollar. Software optimization, and a good example of this is VLLM or TensorRT-LLM. Architecture shifts due to mixture of expert models activating only a fraction of parameters. And quantization such as INT8 or IN4, reducing memory and up to 4x better compute. Now, take note of this. Those 4 factors are incremental. Every single one gets you up to 5x increase. But even though they compound, they are all optimizations within the existing paradigm, so they're all essentially just making the same architecture faster. They're not changing which architecture is competitive. While the 4 signals from the last week are structural. First of all, Google offered their TPU to third-party data centers and tech giants, which means a change in who controls inference hardware pricing, a market structure change rather than a silicon improvement. Then IndexShare went for an algorithmic complexity change by changing the computational complexity of attention. And again, that's not a batching optimization. And then VibeThinker 3B changes what model size is needed for reasoning, a model scaling change rather than a quantization trick. And lastly, TiDAR changed the decoding paradigm, which was effectively an architectural change rather than a key value cache optimization. Structural changes don't compound with the previous factors, they multiply with them. The cost curve did not continue declining at the same rate. Instead, it bent. And the second derivative just went negative. This is the falsifiable claim. Within 10 months, inference API margins for frontier models will compress by at least 70%. And it won't be because Anthropic or OpenAI decided to be generous by cutting prices. But they'll be forced to do so. So in situation where Google serves Gemini on their TPU at a hardware cost that doesn't include Nvidia's margin, it is a structural cost advantage that shows up as either lower API pricing or higher margins. And in a price war, it shows up as lower pricing. For example, the Chinese models like GLM 5.2, DeepSeek version 4, and Kimi K2 are all open weight and MIT licensed. Anyone can host them, and their cost per token is a function of your hardware cost plus a tiny margin. As IndexShare and MLA-style optimizations reduce the compute component, the hosting cost will inevitably keep falling, and eventually, self-hosting becomes cheaper than calling an API. And ultimately, the API provider's margin ceiling is the self-hosting cost minus epsilon, whereby price is just slightly below the total cost of running your own hardware to ensure that the operational convenience and elasticity of APIs remains attractive. VibeThinker 3B proves that for a large class of reasoning tasks, you don't need a frontier model at all. A 3 billion parameters model on a single GPU that you own and costs nothing per token after the hardware is paid for matches the frontier on verifiable tasks. The market for general reasoning at frontier prices is now competing with verifiable reasoning at near zero cost. TiDAR means every model benefits from a 5 times throughput improvement once the architecture is adopted. That's a 5 times reduction in the GPU hours needed per million tokens served, and a 5 times reduction in the minimum sustainable price. The companies that price inference based on the principle that frontier quality requires frontier compute are making an assumption that was true in 2024 and is now, structurally, no longer true. Their cost basis is higher than it needs to be. Their margin is wider than the market will sustain. And they haven't noticed yet because the signals are distributed across hardware, architecture, training, and decoding. And these are the 4 domains that don't usually converge in a single week. The cost curve was bent in the last week of June 2026, and the repricing hasn't started yet.